After the first stage of prettying up, Jupiter's first close-up portrait emerges. Late November 1973, 20 months after launch, Pioneer 10 closes in on Jupiter. Each hour brings the planet 20,000 miles closer. What lies below those inscrutable cloud tops? Could there be life in this maelstrom where pressures may reach 200,000 times Earth's? There are scientists who think that the answer might be yes, that deep in this raging atmosphere of ammonia, marsh gas, and helium, the self-replicating spark may have been struck. One believer is Dr. Carl Sagan of Cornell University.
Jupiter has an atmosphere rich in hydrogen and its compounds, the same kind of atmosphere that the Earth had at the time of the origin of life. So we think that the building blocks of life, at least earthly life, are being produced on Jupiter today, raining down from the skies like manna from heaven. And Jupiter may be a vast planetary laboratory in the chemistry of the origin of life that's been working for about 5 billion years. It's by no means out of the question that there are forms of life in the clouds of Jupiter. And indeed, if you viewed the solar system from afar, I think you could make an argument that life on Jupiter was more likely than life anywhere else, including on the Earth.
Dr. Sagan also provided for Pioneer the famous picture postcard to extraterrestrial life.
But in the remote contingency that there are interstellar spacefaring societies which might someday pick up this derelict, no longer radioing, we thought we would put a message on it to indicate a little bit of where we are, when we are, and who we are. We think that the information on where we are and when we are, indicated in this part of the message by the configuration of certain cosmic objects called pulsars, will be completely obvious to any society capable of traveling between the stars. These two objects will be more mysterious because it is unlikely that there will be human beings anywhere else, even though there may be other creatures elsewhere. And the plaque has served a very useful purpose in making us think about what sort of impression we might wish to give to the cosmos.
Each morning, the key scientific investigators and the key spacecraft personnel meet in the office of Pioneer Project Manager Charlie Hall for a stand-up meeting. Why not a sit-down meeting? Because, says Charlie, people don't talk so long when their feet get tired.
The lack of contrast, I guess, is a better word.
I have the impression that it is all in the fix. I don't know for sure that it is all in the fix.
With such accuracy, but just grossly, whether we can trust the angles on the
I'm afraid to say anything because I don't know. We'll have to get to,
say, 250 degrees or something like that, system 3, which is not far from what the radio astronomers inferred.
We have 3 sets of accurate observations with the ITP this week since the last precession maneuver.
What we're seeing here is that for both electrons and protons, we're seeing in first approximation an in-phase change.
But don't you know, you're not... No, it's all right. You're going up pretty consistently. Yep.
December 2nd, 1973. Tomorrow, Pioneer will make its closest pass of Jupiter, when this fantastic world will fill 1/5 of the sky. Today, Pioneer is being cooked by incredibly severe radiation, yet everything continues to work perfectly. This spectacular picture shows the shadow of the satellite Io, just as Dr. Kuiper's ground-based photo did. But from this distance, new details in the cloud bands become evident. Huge coiling storm areas larger than the Earth. Since launch, Pioneer has been slowing down. Now the pull of Jupiter's gravity speeds it up to a fantastic 82,000 miles per hour. In effect, this crack-the-whip left turn gives Pioneer another rocket stage to fling it out of the solar system. Unexpectedly, the space dust count soars, 100 times as many hits. Jupiter's gravity may act as a cosmic vacuum cleaner. December 3rd. Pioneer sweeps to within 81,000 miles of the cloud tops. Now things happen fast. 15 minutes after closest approach, the spacecraft is targeted to pass out of Earth sight behind the orange moon Io for a critical 2 minutes. This ultra-precise maneuver will use radio effects to reveal new information about Io, if the signal can be picked up again on the other side, and if Pioneer will obey commands again. Back at Mission Control, there's a maternity hospital atmosphere. They won't know what happened in space until 45 minutes later. The speed of light is much too slow for the anxious parents.
Kind of an illustration of how you want to do
Future mission. We have observed the planet in the infrared. We have observed the planet in the ultraviolet. We required the actual probing of the atmosphere.
What did go behind you? Oh, we lost it?
No, yeah, we went out of lock and we were less than 1 second from plan.
And you're back, you're not back on.
No. Oh, it says that's an extra trajectory.
I'll give you the time in a second.
Well, we missed the EO occupation by 1 second, and I was just sort of kidding him or telling him that you have to go through the ecliptic at the right time. When the EO goes in front of you, we're 3 Jupiter radii away, EO's 6 Jupiter radii. You got to get all this thing lined up, and we missed it by a second. Next time we'll do better.
An hour later, Pioneer passes out of sight of both Earth and Sun, this time behind Jupiter. The spacecraft is collecting its worst radiation exposure now. Tension is even greater this time. And so is the relief.
Mark 10 on
Very good. We came out just a little bit later than we expected to, about 40 seconds later than we expected to, but everything worked fine. We went in about 14 seconds later. All the instruments are operating just like they were when they went in. Came out exactly the same way. We're very pleased.
Gee, you're late again.
It's pretty good for government work, Dr. Makes it all worthwhile. It's after 10 years of having to put up with all these people, the 14 hours a day, it's all worthwhile.
Now Pioneer views a sight never before seen by man, the crescent Jupiter. From Earth, we can see only its full phase, like a full moon. These lighting angles give scientists new information. On the television system, the images rapidly become smaller. Now several consecutive pictures can be stored on the tube at once. Thanks to energy literally stolen from Jupiter, Pioneer 10 departs more than twice as fast as it arrived.
This morning,
Now the world wants to know, what have we learned? The scientists readily admit to newsmen that for each question answered, 100 new ones have been raised.
2 different phenomena going on.
Project scientist Dr. John Wolfe reports.
Approximately 44 Jovian radii. We had the indication of very strange plasma distribution.
We're taking back with us to our laboratories data which essentially are puzzling to us and will take a long time to work out.
Some points are clear. The whole Jupiter system is heavier than we thought, by about the weight of 2 Earth moons.
Our most important finding to date
Io has a thin atmosphere. Thus, Jupiter's 4 large moons probably all have atmospheres.
Seeing relatively abrupt decreases in the field magnitude to much lower values.
A compass on Jupiter would point to the South Pole instead of the North Pole.
Through the magnetosphere.
The infrared experiment successfully mapped Jupiter's heat in fine detail. The planet gives off more than twice as much heat as it receives from the sun. Why? Possibly its enormous gravity makes it contract like a slow-motion star. The white belts are cooler, and therefore higher bands of clouds stretched around basically darker-colored material below. Also, the night side and the day side appear the same temperature. Discoveries like these flash out to the world. To experimenters, Some of the most interesting findings concern Jupiter's radiation belts and magnetic field. Pioneer first broke into the magnetic field an incredible 4 million miles in front of the planet. Because of the pressure of the solar wind, this field streams out much farther behind Jupiter. Closer in, Pioneer indicates that Jupiter's intense radiation belts wobble up and down around a magnetic center some 10,000 miles from the center of the planet. In brief, Jupiter is much different from Earth and much more complex than researchers imagined. However, Pioneer proved that a spacecraft could survive the radiation. After encounter, the data tapes for the imaging experiment go to the University of Arizona for computer enhancement. In a meticulous process, millions of data points are juggled up and down the scale. And what emerges is a portrait of Jupiter to challenge the most imaginative artist. While Pioneer 10 journeys to the edge of the solar system and beyond, the information it returned has permitted Pioneer 11 to be redirected to not only pass closer by Jupiter, but to continue on to the next outer planet, Saturn. If all goes well, Pioneer 11 will reach the ringed planet late in 1979. And if it returns pictures, we will know much more about those glittering and mysterious rings. Mankind will continue to explore the outer planets, and sometime in the decades ahead, a robot explorer will descend on Io at the end of a solar eclipse by Jupiter. The sight will be one of the most dramatic in the solar system. During its hours in the freezing Jovian night, Io's atmosphere snows out onto the barren and radioactive terrain, then flashes back from solid ice directly into gas in the span of a few moments. The domain of the outer planets is majestic beyond comprehension. The pioneers, first to brave this land of giants, first to fly forever among the lonely and endless stars of our galaxy, carry mankind's message. We're on our way.